Hi guys, so welcome to the introduction to sequential logic circuits. Before this, we're able to handle combinational logic circuits that don't have to do with memory, don't depend on their previous states. So now we're handling sequential logic, which means that the circuits we're going to be dealing with here, the problems we're going to be dealing with here, they have the kind of feedback that makes the outputs depend on the previous states. Okay, so once we establish this introduction, we're going to be able to understand and create and solve problems involving sequential logic circuits. So what is sequential logic? The main difference between combinational and sequential logic circuits has to do with the fact that combinational logic works with memory, while sequential doesn't. Okay? So sequential logic combinational logic has no memory, okay? So has no memory, or memory independence. Let's do it that way. So it's memory independence. While sequential logic is very heavily memory dependent. What does that mean? So let's say to sort of get an idea of what this means, the very good way to look at this is think of a calculator. So let's say I have a calculator screen, right? And at this point, I perform the operation 5 times 5. My answer is going to be 25. If my next input is going to be 7 plus 10, my answer is 7 plus 10. My answer is going to be 17. If after that I choose to do 4 times 3, my answer is going to be 12. If I choose to do 19 minus 2, my answer is going to be 17, and so on and so forth. So on and so forth. So you can see that this is an example of a combinational logic circuit, because the outputs, at this point we had 17. So this 17 we had at this point, okay, does not depend on the fact that our previous answer was 25, and is not going to affect the fact that our previous answer is going to be 12. So each case of this combinational logic circuit is independent of the states, meaning that if I do 17 minus 2, the next state I'm going to do, let's say 3 plus 2, is going to give me 5, and that's going to be standalone. So that's what I mean when I say combinational logic circuits are memory independent. But a good way to now look at sequential logic circuits is to imagine an instruction that's very dependent on the type of feedback we get. Okay? So let's say we have someone, and we'll call him Robert for now. So let's say we have someone called Robert, and Robert's instruction is to change the states of this door. Okay? So it's going to become very clear that the state of the door is going to depend on what it was before Robert makes the next step. So if at time equals 0, so let's say at t equals 0, the door is shut. Okay? And Robert's instruction is to change the state of the door. So Robert gets to the door, and seeing the door closed, the next course of action is to open the door. Okay? So now we have an open door. So at t equals 0, the time was shut, the door was shut. And at t equals 1, the door is open. Okay? So this is an example of combinational circuits. The reason the door is open now is because it was previously shut. If we were to reverse the situation and say, given that the door is open now, we ask Robert to change the state of the door. So at time equals 0, the door is open. Okay? So getting to him executing the instruction, the door is going to end up being closed at t equals 1. So that's exactly what sequential logic is. So while this is an example of combinational circuits, this is an example of a theoretical example of a sequential circuit. So that's why as examples for combinational circuits, you have things that perform calculations. You have adders, subtractors, integrators, comparators, right? Because mathematical operations don't depend on previous states usually. But in sequential circuits, you have things that you need to receive feedback on what is currently happening. All right. So this is actually called a toggle circuit. Okay. Since Robert is going there to change the state of the door. So that's what's happening in sequential logic. So that's all we have for the conceptual introduction to sequential logic. In the next videos, we look at flip-flops. Okay. Understanding the latch. Okay. We'll do the latch first of all, since the latch is the primary states of the flip-flop. Then we get into flip-flops, we get into gated inputs, we get into clock functions, edge triggers, and so on and so forth. So I'll see you in the next video.